Okay, business algebra, chapter 6 starts with systems of equations and leads to some unusual applications of matrices. So a system of equations, linear equations can be extended to multiple variables. You know this already, we've dealt with them. So ax plus by equals c is a linear equation. When multiple linear equations are placed together as constraints on variables, it creates what we call a system of equations. System of equations can have singular solutions, multiple solutions, or no solution, depending on what the lines look like. These can be found by graphing, substitution, or elimination. We're not going to focus on graphing, but if you ever did need to understand why graphing works, single solution is when two lines cross, no solution is when two lines are parallel, and infinitely many solutions is when the two lines are right on top of each other when graphing. So we're going to start with substitution. So to solve for substitution, or just using substitution, you get one equation. You take the easiest equation you can find to get a variable by itself. Then you substitute what that variable is equal to into the second equation. And then once you get a solution for one variable, you solve for the remaining variable by plugging back in. And then you write your answer as an ordered pair. So for 3x plus 2y equals 11 and negative x, so y equals 3. This y is probably easiest to get by itself, so y equals x plus 3. Once y is by itself, this goes in for the y in the other equation. 3x plus 2 times x plus 3 is 11. That's 3x plus 2x plus 6 is 11. Subtract the 6, we get 5x equals 5, so x is 1. To find what y is, we can plug 1 in. This equation's already solved for y, so y equals 1 plus 3, which is 4. And it's a solution as an ordered pair, so we write it 1, 4. It's that easy. We'll get into more complicated ones as we go, but that's how it works for substitution. My preferred method is elimination. So for elimination, you get both equations in standard form, which is your x's and y's on one side, your number on the other side. You potentially multiply one or both equations to make the coefficients for a single variable equal or opposite, depending on if you like addition or subtraction. We'll keep it as opposite for our purposes. And then once you add the two equations together, only one variable will remain. You can solve for that one and then plug it back in for the other. So here, equation 1, 3 and negative 3 already combine to cancel out x. When we add these two equations together, we do that, we get 3y equals 15. Divided by 3, y is 5. I can take 5 and plug it into any equation for y. 3x plus 2 times 5 is 11. 3x plus 10 is 11. 3x equals 1, which means x is 1/3. What that means is our solution is 1/3 5. So I think at the beginning, elimination is easier, but obviously when you're plugging back in, substitution has the advantage because you already got the remaining variable by itself. In the case that they don't automatically line up for you properly, sometimes you have to multiply an equation by something. Let's look at number 3, for example. Actually, we'll do 4. First, you need to get your x's and y's on one side. It'll be 4x plus 3y equals negative 1. 2x plus 5y equals 3. These don't line up nicely for us right now. However, what we can do is multiply one of these equations by something to get it to line up. So for the 3 and 5 and the y, it's not easy to turn a 3 into a 5. You'd have to multiply both equations, so it's prone to be frowned upon. But to get the 2 opposite the 4, I need it to be a negative 4, which means I multiply this whole second equation by negative 2. So we've got 4x plus 3y equals negative 1, and negative 4x minus 10y equals negative 6. That when I add these together, I get negative 7y equals negative 7, so y is 1. Now I can plug this one back into any of the originals or any of the ones I made along the way. I'll go ahead and plug it in here. 4x equals negative 3 times y, which is 1, minus 1. 4x equals negative 3 minus 1, which is negative 4. Divide by 4, you get x equals negative 1. That means my solution is negative 1, 1. So I still like elimination, but they can get complicated when you have to multiply potentially both equations. There's other situations though. That's where all of those where there's one solution, but what about the ones where there's none or infinite solutions? In both of those situations, both of your variables will cancel out at the same time. We'll do one with substitution and one with elimination. So let's look at number 1. I'm going to use elimination on number 1, so I'm going to multiply the first equation by 2 to get 6x minus 4y equals 8. Then notice when I add these together, my x's cancel and my y's cancel to give me 0 on the left side equals 15. You ask yourself, when is 0 equal to 15? Never. So this is a no solution. What that means is whenever you get 0 is equal to something else, or two numbers that are not equal to each other, you have no solution. That means another way to say that is inconsistent system. Okay, so what about when you want to use substitution? Let's look at number 3. I'll solve the second equation for y, 4x plus 2. Substitute it in. You get 8x minus 2 times 4x plus 2 equals negative 4. Distribute. 8x minus 4 equals negative 4. Our x's cancel, and we get negative 4 equals negative 4, and if we added 4, we would get 0 equals 0. We get 0 equals 0. This happens all the time. Now, it doesn't mean everything is a solution. If we're looking at two lines that are on top of each other, I mean, you still have to be on one of the lines to be on the other one, which means that if my x value is whatever it wants, which is possible, my y value will have to adjust to it. Now, so if I let x be whatever, I know how y is going to adjust because it has to be on this line. Y is going to have to be 4 times whatever x I choose plus 2. So we can simply put that in there. This is what we call letting x be the free variable and y is adjusting. Now, I could do the same thing and solve the equation for x instead. Now, what does it look like if I solve the equation for x? We get y minus 2 equals 4x. Divide by 4. So 1/4 y minus 1/2 equals x. In this case, if I let y be the free variable, x would adjust to y. So it would be 1/4 y minus 1/2. But the major point here is that you let one of them be free and the other one adjusts to make sure it's on the line that it's supposed to be on. So don't just say all real solutions. There are infinite solutions if that's the question. Yes, there are infinite solutions, but those solutions have to be on one of the lines to be on both of the lines. And that's really all for 6.1.